And with that, I'm going to hand things over to Brent. And Brent, feel free if you want to say anything more about the Energy Code training sponsorship from the state and the utilities, please do.
Okay, wonderful. Thanks, Kevin. Appreciate the time. And it's good to see names and faces from my friends in Summit County. Kevin's absolutely right. I communicate regularly with Richard, Jason, and Andy, both by phone and text and email. And I appreciate you taking the time to reach out to me, because that's what I'm here for. And I'd feel really silly if people didn't reach out to me. And I think you guys can all agree that we can have classes and after class after class, but you're always going to encounter a situation where you have a particular building and you need a second opinion or an interpretation. And those are the things that I'm here for. And I'm preaching to the choir to tell you guys that's what you can do, because you know that's what you can do. So anyway, I appreciate that. We are going to talk today about the top 5 high impact energy code provisions and best practices. And these are not the only things that impact energy, but studies, DOE, PNNL have identified these as a top 5, and probably one of them is going to change. We'll talk about that here in just a little bit. Excuse me. Next slide, Kevin. Why all the emphasis on building efficiency? As you guys know, let me get a drink of water. Energy code is a minimum code. We can build so much better. In fact, Kevin had a slide there that had the energy code, then it had the Energy Star, and then it went all up through all these different above code programs. So the energy code is a minimum code. Unfortunately, as you guys know, there's a lot of jurisdictions that are not as proactive as you in the state, and they're not even meeting the minimum. And so that's part of what we're about here, is meeting that minimum and discussing how we can maybe go a little bit beyond that. My experience as a code official is lots of times people want to talk to you about the code and talk to you about insulations and things like that. And if they are given some good information, they will build beyond or above that code. A code building is more comfortable and is cost effective to operate, ensures energy, economic, and environmental benefits. You guys that drive up and down Pardley's Canyon every day for work, because I know some of you live in the valley, know what environmental benefits we would have if we could clean up the air a little bit. And you're probably already noticing it right now as you move up and down I-80, because you can see that blanket of soot that's starting to collect. Then, of course, and some of you have seen this because I've used this slide a lot. What will our grandchildren's grandchildren think of the building efficiency and air quality we leave for them? Are we approving buildings that aren't even to the minimum code? And will one of our great grandchildren be living in that home and wondering what we did? So I think we need to care more about future generations and really be vigilant on our responsibility here. Next. So the 5 high impact things that we're going to talk about today: duct leakage, location, and insulation. We don't see up in our climate zones 5 and 6 as much equipment located in attics and crawl spaces and such as in other locations like Washington County. But in any case, we do see a fair number in attics, and that is the number one thing. If we could get that equipment out of attics, if we could get it insulated properly, and definitely if we made sure it wasn't leaking, that right there is the greatest bang for the buck. Lighting efficiency is rapidly taking care of itself, simply because LED lighting has made so much progress over the last few years. My wife just last night was commenting on the 4 little LED can lights we have in a little coffered ceiling area in our great room. and how much she enjoys being able to dim those, and that they're just the right color of light and everything else. And I put those in 7 years ago and paid almost $40 a fixture for those. And that was a lot of money for those little 6-watt fixtures. But today it's a no-brainer. They're inexpensive. And so that one's going away as the cost of high efficiency lighting comes down so much. It's just an automatic, and something else will take its place. Envelope air leakage, great item. And we kind of amended that in the state, so we're not getting the performance we need there, but we do need to make sure we're at least meeting the amendment requirements. Exterior wall insulation. The whole reason we have all these amendments to the code is because we have builders that still want to build with 2 or 4 walls, and we have one shot to build a wall right. Richard knows my son Jeremiah. He had a home a few years ago that was built in 1922, and you can imagine the efficiency of that wall. And for him to improve that, because it was just double white brick, he ended up having to frame a whole new wall on the inside of the house. So exterior wall insulation, if we get that right, if we make sure we have good quality insulation, that's a huge impact. But then, of course, installation quality, which is a big challenge today with it being so busy. Skilled labor is a real challenge. But we're going to talk about those 5 items real quick, and I'm going to try to go over those in the next 35-40 minutes. It's going to be brief. Of course, you can reach out to me with further questions. Next.
And Brent, I just want to mention one thing. You have you can take more like a full 60 minutes, and we'll just take a little bit less time for the follow-up.
Well, we'll see where it goes.
Okay.
I don't know if these guys are going to have a lot of questions or few.
Mm-hmm.
Duct leakage, location, and insulation. I took this picture while I was down in St. George doing classes in St. George, Washington County, and one of the builders was kind enough to let us come into his house and to take pictures, and we actually did a duct blaster test, and we went next door and did a blower door test. But here's the furnace, and I think you guys will recognize a couple of, and maybe it wasn't in St. George itself, but it was in Washington County. But you'll recognize that the furnace is hanging off some thread stock in the attic, and it's actually over the garage, so that if the coil freezes and spills water out, it doesn't damage the inside of the house. So the first thing is it's located a distance from where the actual outlets are. So it's more ductwork. You guys that are inspectors know that there's no platform and a couple other issues that aren't energy code, but mechanical code. We have sheet metal ductwork that we really don't see if it's insulated inside or not, which it wasn't, and they said they were going to wrap it. But we have this 16 or 18-inch flex duct running across through the attic, exposed on all sides to 140 degree, 150 degree, even 160 degree attic air. And they're an air conditioning dominated market. And maybe some of you know someone that has a property in St. George, or you have a property in St. George, and you know that $300 and $400 or even more is not unusual for a power bill down there. Let me just share what we're finding down there. That the load calculations performed on these homes in hot climates with everything in the attics results in up to a 50% increase in utility cost. What I'm saying is that if you have a $400 bill, up to $200 of that bill is money you're throwing away because the equipment's in the attic and losing 50% of your energy to the attic. And so it's really critical that if we do have it in the attic, that we do a couple of things. We make sure we get it down in the insulation and bury it as much as possible. We really need to make sure it doesn't leak, and we really if anybody were to ask anything you can do to increase the insulation on that ductwork would be the number one thing you could do. We think about it, R8 insulation is the smallest R value that we see anywhere in the code. I mean, virtually everything else, except maybe some pipe insulation, has a higher R value, but yet we have the greatest temperature difference. In the summertime, we're trying to have somewhere around 50 to 55 degree air inside that duct because of the coolings. And then we have almost 100 degrees temperature difference, and we are only buffering that with R8 insulation. So it's really it's a horrible design. And the code is actually moving away from ducts in attics because it recognizes that that's the number one factor. Next slide, please. So after insulation is duct sealing, of course we need to seal the ductwork. The air handlers are now, as defined, they're airtight. They have to be tested to a minimum amount of air leakage, but the ductwork is not always sealed that well. And when we think about it, if we are leaking supply air into our attic or into a crawl space, we are throwing away or exhausting air that we just spent money to condition. So we didn't get any benefit from it into our living space. We heated it or cooled it and then immediately threw it away. If it's our return duct that's leaking, we're sucking in hot air or cold air, depending on the season, into our system and having to bring it not from room temperature up, but bring it all the way up from outside temperature. And so the sealing is very, very critical. I get really frustrated with HVAC people that whine and complain about how hard it is to seal ductwork. It's really not hard if they think about it as they're installing it, rather than put it all together and then just slap sealer all over it. Next. And because it's so important, the code has us pressure test. And so if we have ductwork in an attic, and if you notice in red, the red, of course, is state amendment. Starting January last year, you did not have to leak test if at least 75% was inside the conditioned thermal envelope. But if you have 25% or more of your ductwork outside the thermal envelope, then you need to pressure test the duct for air leakage. And it's just like a blower door test. Basically, you you tape off the registers and grills, and you pressurize the duct system and see how much it leaks. The analogy that I like to use on this is we take that duct system and we put a fan on it. And if I were to compare it to, I don't know if any of you ever had a bad leak in a tire, and you put the compressor on it and it leaks out just as fast as you put the air in it, and you know you kind of have a problem. Well, that's what we do on our ductwork. And when we pressure test a home, we put some pressure on it and we find that point that it leaks a certain amount of air, and we can just maintain a certain pressure on it. And so on our duct leakage test, we take it to 0.1 inch of water column or 25 pascals, which is just a small amount of pressure. And we need to have a limited amount of leakage at that pressure. And then a report's provided on that. Let's go to the next slide, Kevin. And so what the requirement is now, and I forgot again to update this slide. This slide where we have in bold 2,000 square feet equals 160 CFM. If we look over there on the right in red, when we were prior to January 2019, we could leak 8 CFM per 100 square feet. Well, we can now only leak 7 CFM per 100 square feet. So at 7 CFM per 100 square feet, 2,000 feet is 140 CFM of air being wasted. That means when the system's running, we are throwing away 140 CFM of conditioned air we just heated or cooled. We're throwing away that much air every minute that that system's in operation. Well, a good bathroom fan that truly moves 50 CFM, like we're supposed to be using now, we're throwing away 3 times that much air. So anytime our system's running on that 2,000 square foot home, a compliant home is wasting 3 times what that standard bath fan exhausts out of the house. That is really wasteful. Just for information, the code is 4 CFM. And that has been amended. It was basically doubled until January last year, and then it goes down a little bit again in January of next year. So this is a big thing, and if I was still an HVAC contractor, I would want my duct systems down at 1 CFM or something close to that, because I want the air going where it's supposed to go, not every place else. It's like a garden hose that has a bunch of holes in it, and you're trying to water the garden, but 3/4 or half or 1/4 of your water leaks out before it gets there. It just doesn't make sense. I think most of you have seen a a duct pressure test. We have that photograph, the upper one, of the blower door, the duct blaster hooked to the blower compartment of the furnace. Everything else is sealed off. And so it'll just measure how much we're leaking around that air filter and every other connection in there. A rough-in test, he is testing the supply and return ducts separately, taping them off and testing the ductwork before it's buried with the sheetrock, which is kind of a good thing, because then you can find leaks and seal them. Next. Now I took these pictures, and yeah, this is in a basement, so it's not outside the thermal envelope, but I went around and took some pictures for a class I was doing. And isn't it wonderful how we see that they put duct sealer down on the side and they put it on the bottom of the duct, but they didn't put it on top because you weren't going to see it. We need to inspect to make sure all the duct is sealed. Even if we're not pressure testing it, it still needs to be checked for sealing. Now, why is it so important that we seal ducts that are inside our house? Number one, to get the air where we want it. And most of you that have air conditioning and have a basement in your home experience the same thing that I do, is your basement is always cold in the summertime. And a lot of that is because your duct is leaking, and we're leaking that air, that cool air, into our basement where we don't need it, rather than upstairs on the next level or the next 2 levels where we really need it. Next. Same time I was taking pictures, we'll see on the upper right that they did a pretty good job of sealing there. But on the other pictures, they're poor fitting joints and they have not sealed them at all. You can see big gaps. I had a contractor really get angry with me because I was expecting him to seal those gaps. There's no reason for it. Next. And this is where we're going. The 2018 code actually is recognizing and starting to give some energy code credit when we start burying our ducts in the attic. Now, every so often someone tells me, well, if we bury the ducts in the insulation in the attic, we're going to have condensation issues. Well, you might if you're in Houston, Texas, but you're not going to have that problem here. So there's every reason to bury the ducts in the insulation in the attic, and no reason not to. That drastically reduces the amount of heat loss or heat gain that occurs within those attics. Drops it down to around 10% rather than the 40 or 50%. The best solution is if we could get the ductwork inside the house. Now that might take some innovative thought, but it really makes a huge difference. Next, please. Now, if you have someone that asks you, the real best thing you can do is, we have 2 slides here. The upper one is great in our dry climate. We just fully bury the ductwork in the insulation. You know, attic blown insulation is pretty cheap compared to everything else. And I know the concern of some building officials is if we have this duct low, we're not going to get full depth of insulation. Well, the impact on a little bit of reduced depth insulation is far less than the impact of having that ductwork exposed to the hot attic. So, as I interpret the code, you have every right to request that they make sure they put the full depth of insulation. And if you're concerned about full depth insulation at the ductwork, then you can call out, well, we don't have R49 at the ductwork, so we need to put some blanket over it or below sufficient depth to cover it so that we do have a full R9 or R49 throughout the attic. Now, the other thing which really solves a lot of problems, and that the 2018 code and the 21 code are giving you credit for, is if you spray 1.5 inches of closed cell foam on all your ductwork, you not only create a vapor barrier, drastically improve the insulation, but you also seal the duct. And so you have a virtually 100% sealed duct with great insulation, and that actually will perform as well as or better than your ductwork inside the house. Next. And of course, I think most of you have seen this. If they are testing that ductwork in the attic, they should be giving you a report. Okay, next.
Brent, I wonder if we want to see if there's any questions related to
Sure.
to this first section at this stage. Questions, comments?
You got a pretty sharp group out there, you know that? They
I
could
taught them well, Brent.
they could teach it.
Great.
Let's talk about lighting efficacy. I don't know if it's still occurring, but 5 years ago, 6 years ago, we had production builders in some cases that were going around, and they had a set of high efficacy light bulbs that they would put in a house. As soon as it was final, they'd move them on to the next one. I think it's cheap enough to just buy LED light bulbs and leave them in rather than spending the time and labor to move the light bulbs for finals. But at final, we should just verify quickly that 75% of the permanently installed fixtures have high efficacy lamps. And that would include compact fluorescents, tubes, T8 or smaller, or LED lights. Of course, we know that compact fluorescent needs warm-up time and contains mercury. And so I think they're disappearing pretty quickly from the market. And that the rapid advancement of LED is, as I said before, is really going to solve the lighting efficiency issues because we have such efficient lighting. The negative side of this, and it's a little bit more informational for you guys that are inspectors, and you, Jason, as a plans examiner, you were going to see that the 2018 and then in the next year, just over a year and a half, the 2021 comm checks, lighting comm checks are not going to be passing by 50 and 60% like they were in the past because the code is caught up with high efficiency lighting. And so we won't get such a huge bang for it because it's going to be quite easy to just have all those high efficiency light bulbs. There are countless options with LED. Let's go to the next slide, please. And just a chart where you can kind of compare. Bottom line is an incandescent light bulb basically takes 10% of the energy to make light and 90% to make heat. And the opposite occurs with an LED light. We take about 90% of the energy and make light, and 10% makes heat. You obviously don't take an LED light bulb and use it in your Scentsy scented wax thing because it won't melt the wax. It won't keep your engine warm at night. If you put the drop light in with an LED light bulb, it's just not going to do it because it doesn't produce all that excess heat. The thing about excess heat on incandescent light bulbs is, especially during the summertime, all that excess heat is added to your house, and then you have to remove it with your air conditioner. Let's go to the next slide. Now, I know several people that are online here are old enough to remember easy bake ovens.
I have one.
You have one.
Yeah, I have 3 little girls. Of course I have an easy bake oven.
Well, and how do they work? As it says up there, bakes with 2 ordinary electric light bulbs. And
Not as good as I remember when I was a kid.
That's right. You got to find an incandescent light bulb to do it. But it really points out exactly how poorly efficient, or how that they're more a heat source than they are a light source. You put a 100-watt light bulb or a 60-watt, 2 60-watt light bulbs in these easy bake ovens, and you can cook a cake, cookies, or waffles, or whatever you want to do, because the light bulb gets that hot. And it's kind of crazy when you think about it. So many of you have heard this because I've shared it many, many times, but my daughter bought a house about 5 years ago that had 96 can lights, has 96 can lights. And when she bought it, they were all incandescent light bulbs. And I told her when she bought it, she needed to change them, and it was expensive to change them back then. She got a call from the power company that they were going to raise her equal pay in the summer because she was using more than $400 a month in power. This is with, at the time, 3 kids that were leaving all the lights and everything on. And so she broke down. There was a sale at Costco and bought a lot of light bulbs and changed them out. And her power bill, and I can't remember if the number was 34% or 38%. I'll have to verify with her, but her annual energy consumption went down. And I believe the number was 34% by changing out all those light bulbs. Part of it was more efficient lighting, and those with little kids know how they leave the lights on. But a big part of it was she was having to remove all that heat. 3.14 BTUs per watt adds up to a lot of BTUs that you have to remove from your house when you have all those incandescent light bulbs. And that's why it's such a big energy saver, is if we can get those out of there and produce our lighting basically at an 80 to 90% reduction in electrical costs. That's a big number, and that's why it's on the list. Let's go to the next one. Air leakage. And I used this slide in the class that you attended a month or so ago, Jason, so you're familiar with it. We have a Yeti cooler here, and there's a number of companies that make these coolers, and I'm going to break down, and well, if someone one of my kids doesn't give me one for Christmas, I'm going to break down and buy one. But
you want to put their phone numbers up, and I'll drop a hint?
Oh, they've had the hint. There's no question about that. But the experience I've shared is that we like going camping up in the Uintas, up through your area. I go up through Camas and head up into the Mirror Lake Highway, into one of the campsites up in there with my standard cheap coolers. And every 2 days I have to run back down into Camas for some ice and maybe a burger. And that's because my standard cooler will only last about 2 days for the sodas and the stuff that we want to keep in that cooler that won't fit in a little tiny fridge in the trailer. And it's because, number one, they're poorly insulated, and number two, they're poorly air sealed. And you'll notice if you look at any of these, whether it's a Yeti or a Pelican or a Lifetime, or there's a whole bunch of other names, that they all have solid foam walls and lids, and they all have a gasket on it. And that is to reduce the air leakage. And it makes a big difference if you can seal the air in there, and we don't have that convection of air flowing in and out of the cooler And that's one of the reasons that you go 10 or 11 days with one of these coolers with a load of drinks and ice versus the 2 days. So it's about 5 times longer. Increased air sealing and increased air insulation. Same things that we can do on our house to make them.
Brent,
Yes.
what do you do about the burger that you pick up every 2 days?
Well, you know where they go, right? And you know where I get them, right there as you come down out of the canyon there.
But I'm just saying, you get one of those coolers, you aren't going to get a burger every 2 days. You got to think ahead.
Well, I guess I'm just going to have to take more burger patties with me and make my own burgers, right? We'll still go down once in a while, but not every 2 days. At least to get a shake, right? Let's go to the
Have
next.
you had the donuts from Camus? That's what Camus is world famous for.
Oh, they have a lot of good stuff there. A lot of great stuff. I love Camus. Let's talk about insulation and air barriers, because we need to think about this a lot with our insulation. And this is a big part of my building science presentation. When we think about insulation, you can have a fleece jacket like on the left, or a sweater or something like that, and it's wonderful until we get a breeze. And then the air moves through it and the insulation is almost useless or worthless. But you put that windbreaker on, or something that stops the air barrier, it stops the movement of air from scrubbing away from those stagnant air pockets that we have within our insulation. And it is the exact thing that we need to try to do with our fiberglass insulation and our other insulation that relies on air pockets that is not closed cell. If the air can move through it and we don't provide an air barrier to stop the air from moving through it, then we're going to have greatly reduced R value on our insulation, and it becomes ineffective. Let's go to the next slide. Here are all the areas the IECC focuses on for air sealing, and we're not going to go through the whole list. That would be a big list. But I did want to point out just a couple of them, and I have the arrow by them. And that is when we have flues or chimneys, fireplaces, and garage walls. And of course, if we have a flue or a chimney, we have combustion taking place inside the house. And if we are not using direct vent appliances, which I highly recommend, never put in a gas appliance anymore that isn't direct vent or sealed combustion. If we have open combustion and open flues, open chimneys, we have the potential not only for carbon monoxide and all that, but we have a chimney that drafts heat out of our house all the time. And the little dampers in chimneys for our wood burning fireplaces don't seal tight. If it's a gas log, you have to permanently fix it open so that it just drafts heat out of your house all the time by that chimney action. The space between the house and the garage is a big one, because we have a lot of carbon monoxide deaths every year because of air leakage between garages and houses. We wrap Tyvek around the whole building, do a nice job, but we don't put Tyvek on that garage wall that separates the house from the garage. So there at number 15, we really should have an air barrier there to ensure that it's airtight at that location. Let's go
Hey,
to the next slide.
Brent,
Yes, go ahead.
is that code?
Well, it's code that we seal, and in fact, we're going to get into a couple of slides real quick here before too long. The amendments to our code basically give us 2 options on making sure our house is tight. And so yes, it is code that we seal everything. It's, kind of subjective on inspecting all that. And we'll get to those slides, and then we'll take your question back on if it doesn't answer it. Can a home be built too tight? I've asked this question. I ask it all the times. And of course, some people say, yeah, it can be too tight. And In fact, the late great Bill Vanderlyn and I had big discussions on this 12, 13 years ago on building too tight. And I maintain, and I still maintain, that we can build a house as tight as we want, as long as we just ventilate it properly. And I think that's an important thing for us to remember: build it tight and ventilate right. Because if we don't ventilate right, we have the CO2, and we build CO2 levels within our buildings, and that's not healthy either. And so, yeah, we need to be careful. If we build a house tight and we don't ventilate, then we have a problem. Next. We've learned some hard lessons over the years. Back in the 70s, we have an energy problem. They'll turn down our thermostats in the winter, turn them up in the summertime. We're miserable all the time. And we'll throw vapor barriers everywhere, trying to seal and hold moisture and everything. And we had a lot of problems with those. I've shared the experience I had back in 76, where they, for just a few months, wanted vapor barriers on the ceilings. And a building I was working on down in Salt Lake County, doing the HVAC, they put a vapor barrier up, then drywalled it, brought in the salamanders to dry the mud in the middle of the winter. And the next morning, the drywall off the ceiling was sitting on the floor because the moisture went up, saturated the drywall, and it fell down. So there were some hard lessons learned. And number one is that we can't rely on natural ventilation, just opening windows. And number two is we have to be concerned about moisture and where it's going to condense. Let's go to the next slide. So we need to build a tight building. It decreases energy use. We design a ventilation system that's proper, which is real important now. There's lots of discussion on ventilation and can we control virus with ventilation? And we can do a good ventilation system and minimize the risks there. We can provide acceptable indoor air quality, decrease health risk, and reduce complaints and reduce moisture level, but we have to do it right. So let's go to the next slide. And so and this gets to the question, without amendments, every home built in Utah should have a blower door test. And we have a picture there of a blower door. I'm not going to spend a lot of time on it, but we either pressurize or depressurize our house with that little fan in the temporary door, in the front door, or whichever door you want to put it in. And we measure how much it leaks. And it's a pretty simple, straightforward process. But we do the blower door test, and without amendments, we're supposed to test at 3 air changes per hour or lower. The state and we're supposed to do a field verification. We have a table we're supposed to follow. So we are supposed to, by code, follow a checklist of how we air seal and how we install insulation and blower door test. The state amendment says we can do either the blower door test or we do the field verification. It gives us an option. Let's go to the next slide. And so here's what we have. Here we have that checklist. And so back to your question, walls, it tells you everything that's supposed to be sealed on the walls. It doesn't say the garage wall. It says it's any wall that separates conditioned from unconditioned space. And so the house to the garage is conditioned, unconditioned space. And then it tells us how we're supposed to install the insulation. And so in Utah, they have the choice, do the blower door test or do this checklist. We need to make sure that they are doing at least one of these. Now, if they do the blower door test and they are tighter than 3.5 air changes per hour on everything but townhouses, they do have to provide mechanical ventilation. The flaw in our state amendments is that if they choose to do the checklist, they build a tight house that's too tight for all intents and purposes, but they're not required to do mechanical ventilation or make sure that you have good air quality. And so we are having homes that get built they don't blower door test, we don't have a trigger for mechanical ventilation. And so we end up with basically sick homes. They're going to have problems, and it's because we have poor state amendments. So I guess the number one thing that I could say here is we need to really be encouraging that they at least do the Panasonic or high efficiency fan someplace and have it running all the time for mechanical ventilation. We'll talk just a little bit more about that here in just a second. Let's go to the next slide.
So just to be clear, every house that chooses to do a blower door test is going to have a whole house ventilation system now.
Well, almost. The state amendment says that they have to test to 3.5, but the state amendment
till 21st or
Yep.
till 2021.
Yep, until next January. Yeah, like a month away, or less than a month away. The trigger, which is also a state amendment, was dropped from 5 air changes per hour to 3 air changes per hour. So if that blower door test right now falls in between the 3.5 and 3, then technically you don't have the ability to, or the legal ability to tell them they have to mechanically ventilate. But if they go below 3, then you do. The big flaw in the whole amendment is that you don't have to blower door test. And so we have hundreds and hundreds and thousands of homes that are tighter than 3 and actually tighter than 5. I don't know if you remember or not, Jason, but the trigger in the code is if you're tighter than 5 air changes per hour, you should mechanically ventilate. Now, if I were a legislator, I would be a little bit concerned that we amended the code and just arbitrarily dropped the number 40% down to 3, because the trigger was put at 5 because when you get tighter than 5, you really need the fresh air. You need to do something for fresh air. And so, you know, this gives me more heartburn than anything else in our state amendments, that we've broken the code by doing this. I threw this slide. Does that answer your question, Jason?
Yeah.
I threw this slide in. If you choose not to blower door test, you have to go through that whole list. And one of the things on that list is that the rim joist has to have an air barrier on it. So we're looking at this picture of a rim joist. How's the standard way to insulate them? They shove a piece of fiberglass insulation in there. Well, it doesn't have an air barrier on the face that we can see. It has air barrier around it because it's against the rim, it's against the joist, it's against the top of the foundation, but it doesn't have an air barrier over the front, you know, what we can see. And so really the only way is they are going to do the insulation, installation, and air barrier checklist. The only way they can meet that table is to spray foam, spray closed cell foam like they have here. And then that solves that issue. And, you know, really the more I see and the more construction defects I observe, that right there is one of the best things that anybody can do is, number one, spray at least 2 to 3 inches of foam in your rim joist. And then next behind that would be spray 2 inches of foam minimum in your wall cavities if you're not putting foam on the outside. And this ties our envelope air leakage with our insulation, our wall insulation. You know, they go hand in hand. Let's go to the next one, Kevin. And yeah, so beginning in January 2001, it's 3 air changes per hour on a blower door test. And it'd be great if we all got behind that one. And when they say we're going to blower door test, just tell them you are going to need to mechanically ventilate, because they do need to, and they should be doing it already. If there's anything we could convince people to do by just talking with them, it would be to point out to them how important it is to mechanically ventilate their house and not rely on opening doors and opening windows to maintain air quality. We still have the amendment that isn't going to go away, and I don't think the legislature is going to do anything on it until they consider the 2022 code, the 2021 code in 2022. And that's the 5 air changes per hour is still allowed on townhouses.
I have a question.
Please.
Do the inspectors, do you guys have blower door tests that you take in and use?
No.
No, it's third party.
Oh, I see. Okay, thanks.
Great question.
Brent, this is Andy. I got a couple questions for you.
Okay.
So it seems like in the whole state, in my city and Summit County, we're seeing a lot of multifamily, which have the least amount of restrictions, like, for example, the blower door test, as well as, because of the nature of the product, the quality of install. I would say multifamily is probably the hardest thing to meet code minimums. But as building officials who are limited, what are our recourses? What do you think the best way is that we can encourage these contractors to make that product as best as possible, given the conditions we have from the state?
I wish I had that crystal ball and could come up with the best thing we can do. I think probably the best thing we can do is make sure they're doing everything that the amendments require. If they are choosing not to blower door test, we hold their feet to the fire on the checklist and every single item. I think if you do that, they're going to say, oh, it's going to be easier for me just to do the blower door test. But to pass the blower door test, as it's getting down to 3, they're going to have to do all those items anyway. To get them to buy onto it, I don't, you know.
The problem is we have a lot of, single family dwellings that, like you said earlier, they're more than willing to do way above code minimum on. But I've yet to see a high-end townhouse or multifamily builder. They're usually the cheaper, lower end. And I've yet to see one that even wants to talk anything beyond 4.2% above the res check. You know what I mean?
Yeah. No, I do. And there is one thing that you can talk to them about. And this is better than nothing, is if you can have a discussion with them on mechanical ventilation, so they at least make an effort on the mechanical ventilation. They are going to minimize their risk on condensation. They're still going to have condensation issues. We were going to have in 10 and 15 and 20 years. In fact, I was involved just months ago in a project, and it was townhouses in your jurisdiction, and it settled out of court. It's over there. I can't remember the name of it. But anyway.
Redstone?
I'm sorry?
Redstone?
No, it was across the street, almost across the street from the gas station, the intersection that was all tore up for a year.
Oh, Jeremy Ranch. It was the Pine Brook one's in.
It was over on the Pine Brook side, and it was just a little circle, kind of a little loop road.
Uncle Doug's?
No, above Uncle Doug's. It was Jeff Peterson built them with, and it was just as cheap as they could go.
Yep. And guess what they had?
Mold.
They had a lot of water intrusion from outside, bulk water, but they also had some condensation issues, behind walls and stuff like that. And they're building cheap, and that's not the only litigation on townhouses right now. There's a number of them that they've had to tear all the stone off of fireplaces, all the cultured stone and stuff, because they thought it was a great idea to put ice and water shield all over it. And so they've created a vapor barrier that the moisture from inside comes up against it and condenses, and so the OSB is falling apart. And really, if we did the whole thing according to the code and we blower door tested and we did the ventilation, and where the code's going, and it's already in your jurisdiction, and it's the next item we're going to talk about, exterior insulation, R10 on the outside. R10 on the outside and mechanical ventilation are the two biggest things that they could do to minimize their risk. Anyway, I wish I had a crystal ball or I could wave a magic wand and get everybody on board, but that's why we're talking, you know what I mean? Those that aren't doing anything need to step up and do a little bit. You guys that are doing so well, you're looking on how you can do better, and that's why we're here. So let's jump to the next one. Kevin's going to get nervous on time. And here's exactly what we're talking about, townhouses. And they're slap them together. And those arrows point to all the places that we're going to have air leakage, that we got to make a little bit of extra effort to make sure they're not leaking. And it doesn't happen most of the time. The cantilevers, of course, the space between the two units, because we're not putting a Tyvek or anything there, so they leak back and forth between units. And the builders don't seem to put a priority on that, where I would put a priority on it, because if you can stop all air leakage between there, you're also going to stop the odor issues. You know what I mean? The one person that cooks something that the other person doesn't like. And so we have a lot of challenges with our multifamily, and you've nailed it on the head. Let's go to the next slide. So our best option, just ensure that they're doing the checklist or the blower door, inspect all the checklist items, ask for the reports. I would even recommend once in a while you ask them when they're going to do a blower door test, and you go by and witness it. Just, if you have the time, just to kind of keep them honest on those things. But they need to be aware right at plan review that if they hit below 3, they have to mechanically ventilate, and they should just plan on doing it all, right from the start. Let's go to the next one. Have any of you guys seen them do this, the aero barrier, where they put a blower door on and pressurize the house? And this is a water-based product that when you pressurize the house, it pushes it to the leaks, and it will seal up to a 1/2 inch gap. And you see the little graph when they started out, how much was leaking, and they got it from basically having a 1,000 CFM of air leakage, or the equivalent of a 125 square inch hole, or 9.79 air changes per hour, down to 0.89 air changes per hour, simply with this product. Now it costs, and I'm not trying to sell the product, it costs $1,000, $2,000 to do it, but this will seal up a house and maybe save a lot of steps in the construction. And I've observed it twice. It's kind of a cool product. I don't know if any of you have ever seen it, or there's some YouTube videos that are pretty cool on it.
Hey, Brent, while we're on this topic, I just wanted to point out that the Habitat for Humanity chapter up in some and Wasatch counties will be using this on 2 of their single family homes in Silver Creek Village, I think it's what it's called.
Yeah.
And one of them is getting to that stage pretty soon. So it'd be a good opportunity to come see it in action.
Is there a way we can be notified? I would like to go see that.
Yeah, I'll take it up.
It's a slick process. The best time to do it is right at this stage right here. You've drywalled and taped, and so wherever the leak is, it'll find it and it'll seal it up. And going from almost 10 ACH down to 0.89, that's pretty significant. And the cost of that versus the savings, the return on investment, and the lifetime savings over the life of the building is huge. I mean, just absolutely huge.
We've got quite a few contractors that have started using that, and that basically guarantee their clients, a certain amount of air changes per hour. It's a pretty cool product.
Yeah, And of course, if they're doing any of these things, you really need to have a good discussion on mechanical ventilation. We're not going to have a lot of time to spend on that. But of course, you can always reach out to me, and I have some presentations on YouTube on our Utah Energy Code website that you can go to, where we talk about it in more detail. Let's go to the next one. And so this is what we've already talked about. If we get tighter than 3 air changes per hour, we need to do something about it. We do need to make sure, while we're on this, that we have gravity dampers, automatic or gravity dampers on all of our air intakes and our exhaust outlets, because that's a source of leakage. Let's go to the next one, Kevin. And exactly what we've been talking about: build tight and ventilate right. After source control bathrooms and kitchens, it's critical that we have some continuous ventilation that just keeps the air quality good all the time. And the other things we can do is make sure that products aren't being used that have formaldehydes and such products. Opening windows does not work. If we're in an area with radon gas, we should be testing for that and make sure we are addressing that as part of our solution. And then big one. This is one over the counter that people up there, they're not afraid to do what's right. Make sure that their water heaters and their furnaces are all direct vent. Both pipes are ran. Don't let the HVAC guy get away with running one pipe and then bringing in the combustion air duct, that we have all the issues of trying to seal that in a room. It's unreasonable to expect we're going to stop bathing, cooking, breathing, cleaning, washing, drying, hobbies, etc. All those things are going to contaminate the inside of our house. And so mechanical ventilation is the answer to that. And like I say, it might be just a little fan that's just running all the time that you can't even hear. Let's go to the next slide. Our 3 choices, and I think I've used my time, so I'm going to move quickly. On the bottom left, we can use our HVAC system to draw a little bit of air from outside into our air handler. This isn't my #1 choice, because your fan has to be running all the time, because the code requires continuous ventilation. The second one is a small fan, and this is the whisper ceiling is I believe this one is a Panasonic, but there are other manufacturers making them. They're DC motor, ECM motors. They use barely the power that a doorbell transformer uses, so they cost almost nothing. It can be one of your bath fans, or it can be a fan that you put in a hallway and you just hardwire it so it runs all the time at a calculated CFM that might be 30, 40, 50, 60 CFM, depending on the side of the house. And it's constantly exhausting that amount of air, and we're relying on leakage to replace it. When you get super tight, that won't work, and you need to go with heat recovery or energy recovery ventilator, which basically exhausts a certain amount of air, replaces it with a like amount of air from outside, and recovers the heat from the air we're throwing away. And so it's efficient, the most efficient ventilation we can have.
Hey,
And
Brent,
go ahead.
what's the difference between an HRV and an ERV?
An HRV is sensible heat only, and that's what we typically used in our climate. An ERV, the best way I can explain it is, if you're in a humid climate, we don't want to exhaust air that we dehumidified and replace it with real humid air. And so they have desiccant materials in their heat exchangers that absorb the moisture as you're bringing in your outside air, and that it is transferred to your outgoing airstream. And so we bring in fresh air but moisture, and we exchange the heat, but we also send the moisture back out with the exhausted air. And you might have seen them with big wheels that turn with the airstreams. Those are ERVs. Actually, ERVs are becoming more and more popular, because I've had HRVs and installed a lot of them. And in our climate, they tend to dry out our house because we remove the moisture In fact, we remove it so much that we end up too dry. So we might humidify to bring it up a little bit, and then we suck it all out and have to humidify some more. So it's a discussion that really takes a half hour or something, or an hour to go through. Jump on YouTube or give me a call, Jason, and we can have additional discussion on it.
No, that's good enough.
I think it's something that I should probably write something up and put it on the website, so that, because it's a great question. Let's go to the next one, Kevin.
And Brent, you have the full 10 minutes. Maybe try to leave a couple minutes at the end, just in case there are a couple more questions.
Okay. All right. This one won't take very long. I think we're pretty much familiar with our requirements. If you notice, the thing I want to point out, prescriptive table, if they go prescriptively in your climate zone 6, the code says you absolutely have to have some form of exterior continuous insulation. R5 with an R20 cavity, or R10 with a 13. And actually the 10 with the 13 is a better option than the 20 with the 5. It gives you better performance. Ideally, you put that 2x6 wall, you blow R23, R24 with net and blow, and then put R10 on the outside, and you have an incredible wall. And that would be the wall that I would build if I were building a new house. But anyway, the reason we have that, and I think we've had this conversation, Jason, and maybe Andy and maybe Richard, about the condensation issues we have on the backside or the inside surface of the OSB. And this is the whole thing that code's headed towards, is trying to eliminate that condensation by putting some continuous insulation.
Do you see the cost of that continuous insulation coming down? Because it's really expensive, isn't it? At least it was a few years ago.
It's not so much the material's expensive, is it creates challenges around your doors and windows. How do you buck the windows out, and how do you trim around the windows and everything? And there's some solutions. People have come up with some ideas. It is a little pricey, but if they're doing EFA systems, they're kind of doing it already. But most of them aren't doing that. Go to construction instruction, and some of you are familiar with that website and the app they have, and they have a bunch of videos in there, and they have a calculator and everything that shows the value of doing that exterior sheet insulation on the outside. But whatever the case, whether they go prescriptive or they do a res check, or whatever the case may be, if we can get the wall insulation correct, we're way ahead. Now, I do want to point something out. Air spaces or air gaps in our wall insulation are the enemy of insulation. I remember so many houses that I worked on that they had a step foundation, and so they just frame a wall all the way across that whole that sidewall in the basement, and then they insulate back against the exterior wall, and then they insulate the interior wall, and they have a big airspace behind. And what you end up with, that big airspace between those two layers, is a lot of convective flow, or air rising and air falling, and we're getting these convective circles going around in those cavities. And that air movement is destroying basically countering the R value of the insulation. And so if you have those types of odd cavities, they really need to be filled with insulation. That's the only way they're going to be effective. And how do we go there? The inspection checklist that says you have to have an air barrier on all sides of the insulation. So in those cases, you just fill it up, because you're not going to be able to put air barriers on both sides of that insulation. Back to your question, Jason, I think it's probably more expensive to spray the foam inside than it is to put the sheet foam on the outside, or the cost is similar. Let's go to the next slide. You all know the prescriptive table. I don't need to spend any more time on that. Just note that this is the baseline where we build off of, and your climate zone 6 is pretty much the same as it is in my climate zone 5, except for our mass wall and our wood frame wall. Everything else is the same. And slab insulation. You're 4 feet instead of 2 feet. Next slide. Significant portion of the the residential ICC focuses on the envelope. I mean, that is the major focus of the residential ICC. All those components, you know what they all are, anything that separates conditioned from unconditioned space, and every bit of that should be accounted for at plan review and at inspection, and making sure that everything is insulated and insulated properly. We need to know those R values and U factors at plan review, and they need to be on the plans, and then they need to be checked at inspection. Let's go to the next slide. What would you recommend on that one right there? My recommendation would be insulate the roof line all the way down, put a lid on that insulation. You, of course, need to deal with either ventilation in that rafter space, or we do the spray foam that's required by the code, or maybe you guys allow the membranes, the smart membranes. But the knee walls create a lot of problems, especially if you don't have the top plate, especially if you don't put the air barrier on the backside. In fact, how many times have we looked into one of those spaces and the insulation has fallen out and we have no insulation there? So we have some problem spots. Notice the blocking for that floor ceiling insulation with the light in it, that cavity, that horizontal cavity. There should be a block at the end, again, to side that insulation. Next slide.
Hey, Brent, can I just tell you, when I started back in 1999, I went out to a house with the building official that was built, and they was complaining because their upper level was cold. We had a knee wall just like you've got on that, and we got back in there and they hadn't insulated it at all. And I still remember the building official saying, well, I guess we're going to have to start doing insulation inspections now.
You make a great point. I had just started inspecting, and I went out, and I was still at Salt Lake City, so it was in the first year and a half, and the insulation was installed horribly, and so I failed it and wrote up about 30 items that were wrong on it. And the guy absolutely freaked out of his mind that I dared fail an insulation inspection. It was kind of bizarre.
Well, yeah, we used to walk in and say, yep, it's insulated, see ya. And now it's a half-hour inspection.
And that's important because you have that one chance to get it right. Let's not forget, when we're talking about walls, everything that I have in green there is a wall, which includes the rim joist. Next, and we're just about done, Kevin. Some of you have seen this slide before, and I'm just going to real quick go to the two images, the two thermal images. This is my house. The bottom one has continuous insulation on the outside. These were taken the same day. The upper picture is a closet wall that I haven't had the opportunity to do the insulation on the exterior yet. I haven't pulled it off that end of the house and insulated it. And you can see that by adding insulation to the outside, I've drastically reduced the heat loss through the studs. Those pictures are pictures of heat, and where it's dark purple and going towards darker purple, that means the surface of the wall is colder there, and it's cold because of heat loss through the wall. By me putting continuous exterior insulation, and I even went so far in the right picture, I put a 1/2 inch of polyiso on the inside also, and it really made a big difference. That's a piece of R3 on the face of this stud. That's as much as the stud was. So makes a difference. Thermal bridging is a big factor, and that's why I'm such a fan of exterior insulation. Next slide.
Those screws really make a big difference. Like even in the second wall, you can see every screw.
You can see every screw because why? Because they go through the insulation.
Transferring.
They go deeper into the stud.
That's crazy.
Yep. We already saw this table. The right-hand column is how we install the insulation, and the number one thing on it is the insulation has to be cut and fitted around everything. Installed per the manufacturer. Let's go to the next slide. We should, if we turn them down every time they didn't cut to fit around every wire, cut to fit around every box, they'd throw their hands up in the air and say, it's not worth it to put bad insulation. I'm just going to do a net and blow system, which would be a good thing. Let's go to the next one. These are pictures I took, and the one on the bottom right with the yellow, that's my house when I stripped the drywall off. I was really proud of them when I pulled that off.
I just want to say that was pre-2003.
92.
Yep. So that's
Yep.
not me.
No, it was pre.
Hey, let me just, so if you take the time to actually cut in the bad insulation around all the wiring, and that's a huge labor cost, would it still be cheaper to do bats?
I don't think so. I think if we, I mean, the manufacturer's instructions say you need to do it that, how you have to do it. And the code says like 150 times to follow the manufacturer's installation instructions. On the left there, they've packed it in rather than cut it. There's just so many things. If we required them to do it right, I think they would just say, you know what, we're just going to net and blow, and we're going to get more R value, and it's going to take care of all those issues. That's what I think we really should be doing. Let's go to the next one. I think you've seen these, Jason. I walked into a house because I used these before. I just took them a few months ago. Walk into a house, it's all cleaned up, just was drywalled, and here's a big piece of insulation, then a thin piece of insulation laying on the floor. You know they're missing from a wall cavity someplace, and they didn't care about it. The next one, we have fiberglass missing out of the fur down, sitting on the floor. You know that doesn't get put back in place. And then if you look at that insulation, it's not installed very well either. Next, and we have a vapor barrier pointing out in the garage. There's what we should be doing. I mean, that simple step right there, just doesn't that look 100% better?
I think you'd have a lot less total loss house fires too.
Yeah, well, you eliminate all the spaces for fire to track, and you eliminate. I mean, there's just so many reasons to do this, and it has a higher R value, up to R24, depending on which product and how dense they blow it.
Oh, it gets higher than that. They tell me all the time on the res checks ain't getting R28 out of that.
I'd like to see some documentation on that one.
Says it right on the res check, Brent.
Oh, that's okay. Next, two older homes on the right. They don't have an insulation problem, do they?
Looks like mine.
And then my neighbor straight down the road from me, you see that where the two arrows are, that's where two angle boots are for his HVAC system. And of course, we have heat loss when there's snow on the roof, but we have heat loss all the time because they didn't insulate the sheet metal boots when they did the HVAC system. Next. And we can't end without talking a little bit of slab edge insulation. It's really not wall insulation, but it kind of is wall insulation. And this is one of the the big ones that if we have slab on grade, we really need to be vigilant in making sure this occurs. Next. And I don't think we need to review them, but those are the 5 things we just covered. And appreciate your time, appreciate the discussion. Really great to have that discussion. And I believe that's my last one, isn't it, Kevin?
Yep, it is. Thank you, Brent. And I also appreciate the questions and discussion throughout. We had scheduled this for 90 minutes. If there are any last minute questions or comments, I'm happy to take a couple more minutes before we formally close.
I'll say something, please. This is Peter. So in regards to the fact that most of the people on this website are keen and interested and have a degree of expertise and experience in everything we've talked about, on the other side of the question is the Utah Home Builders Association, who feel that every single person involved in this website should have no interest or involvement in their houses whatsoever. And they're down at the state legislature lobbying every year to make sure that maybe perhaps building inspectors themselves should become an endangered species. How do we go about guaranteeing the quality of the product? The best specifications in the world are completely useless if they're not installed properly.
I wish I had the answer. All we can do is keep moving forward. The thing that I've done, and I think it has helped a bit, is I have tried to not be adversarial when I talk with the home builders and such. I've tried to really reach out in a sense of, cooperation and such. And last time the legislature discussed any of these items, oh, his name just slipped my mind. The guy that's the legislator that's now doing building codes.
Mr. Schultz?
Ray?
Yeah, Schultz, Mike Schultz. He invited me up there with just Taz and Ross from the home builders, and he was, well, and he had talked with Kevin, and he actually, it's the most positive experience I've had with a legislator since I've been involved in it. What's your opinion, Kevin?
I think you framed it well. Yeah, I mean, I think that was a good example of where there was a productive conversation. Well, yeah. I mean, and I guess I would just respond in addition to Peter's question is really that's, I think just highlights how important plan reviewers are and building inspectors and building officials in general are in making sure that the long-term public interest of community members and not only their comfort and costs, but also the energy and pollution impacts associated with using energy in our built environment. That it all comes down, it really comes down to you. You're the ones there looking out for the public well-being. And there's some builders who aren't, who are building great product, and obviously there's a role for you because not everyone is building the kind of product,
Yeah, that's great, Kevin. And the thing, I guess my biggest point I'm going to say, and Summit County is not the issue. My big focus right now is getting those jurisdictions that aren't trying to try. So at least if the whole state was trying to at least comply with the code as amended, we'd be ahead. I am going to reach out to Mike, and I'm going to ask him if we can, before too late in 2021, start the discussion, because we need to revisit the discussion on ventilation in light of the COVID issue. And I think maybe we're going to have a more captive audience because there's a lot of legislators that are interested in this and wanting to be aware of what can we do to make our buildings better. And the big thing is have a code that's not amended and then enforce the code the way it is.
So not to get into an off-topic discussion, but you mentioned with the townhouses and the free movement of air between units. Do you think it's possible that we're spreading COVID from unit to unit to unit without actually even coming in contact with those people?
Probably unlikely from
okay.
That's not a very professional opinion, just because I think the air movement through the wall is going to be filtered enough, through the insulation and stuff, that we're not going to get the droplets through the wall.
Well, it just It's always kind of blown my mind that we're so worried about a car idling for 10 minutes, but we build thousands and thousands and thousands of houses every year, really to a watered down 2006 energy code. And no one says a word about it, but don't idle your car.
Yep.
That's because every time on the nightly news, I look at a weather forecast that says Salt Lake is suffering from haze. Why don't you call it what it is? You know, it's a dreadful, you know, collection of air pollution that's been created by ourselves. And there is the power to do something about it. We just need the political will to choose to do so.
Yeah.
And you know what? Go ahead, and then I'll make a closing remark, Lisa.
I was just going to add, you know, back to Peter's question about how to get builders to build and comply, fail them. I mean, if they don't comply, they fail. And you do that a few times, they'll start making sure it's done right the first time. And I think that has to be industry wide. But if this stuff is let go by, and I'm not saying anybody, I'm not saying who does let it go by, but I think that's really key.
Well, I think Summit County, our inspectors, we do a pretty dang good job. But the problem is, like Brent mentioned before, this is the bare minimum code. This is the absolute bottom line, what you can do. But to us, it's our maximum. It's the maximum that we can ask for. We can present ideas and we can present solutions, but we can't ask for anything beyond the bare bone minimum. It's our maximum.
No, I understand that, but if they're not installing the bare bone minimum correctly, then the house doesn't pass the inspection. Then they go back in and get it right.
That's the problem, Lisa, that to the extent that the code has been modified by the state legislature, they probably are getting away with stuff because we're not allowed to test it to the extent that we should. Brent, you don't know, I'm actually an architect by training, and I've designed many buildings in many locations. But when I first built a house in the state of Utah in the local area, and I actually asked the contractor when he was going to pour concrete, and I went out to visit the site to meet him on site before the concrete arrived. He told me that I was the first architect he'd ever seen on a building site. And I was stunned at that point. You know, it's like, but I'm no longer surprised by that. That was a number of years ago, but I know many architects who try and design to a high level, write a high level of specification, and never once step out of their office and go and see what is actually built.
Yeah.
Thank you. Oh, I wish we had some more time. In the interest of just recognizing the time that we had set for this, and the fact that we have the opportunity